Welcome into this video. We're going to cover a requested question on Wyzant dealing with the statistics of standard normal distribution. And you can see here it simply asks us to find the probability between two z values. So of the z, standard normal distribution, literally, right? And these two values are negative 2.64 and negative 2.23. Now, to the left on your screen, on our screen here, you can see the normal distribution curve, and it is set in terms of standard z-scores. And the only values we're seeing are those two. We don't really care about the other ones because we're just focusing in on finding the area between those two values. But you do see the 0 at the center, representing the mean of the normal distribution. Because as you know, for the standard normal distribution, as you know, the mean is always 0 and the standard deviation is always 1. Okay, so it's good to have an image of that either in your mind or better yet on your paper. And it just reminds you of what you're looking for. Now to the right, I just wanted to briefly mention a couple ways in which you can find the probability of z-values, because it's up to you depending on the resources you choose to use or that you have, okay? Now the first one is the z-table, really, really common, right? This was before maybe the calculator. And this is always a reliable one, but do keep in mind that it is of approximated values. So it's gonna look something like this. Okay, this is on a website literally called z-table.com. Okay, but if you have one in your book, your textbook for the class, if you have that, use that, of course. It's probably gonna look something like this, and there's maybe 2 pages. Okay, because you got z values that are negative to the left of 0 and z values to the right that are positive. But both of the values we're dealing with are both negative, so we're just going to stick to the left or the first set of values. Now, the other way is to use a calculator or some computer software like Excel, because sometimes you may just want to do it like that instead of using the table. I don't know. But it does give you more precise values, and it leaves it up to you to approximate it, okay? So again, the z-table already the probability or area values you see. That's to the right of the first column. That's the first part of the z value. And then below the first row, that represents the other part, the hundredths place of the z value. All of those areas are out to 4 decimal places, right? So just keep that in mind. And when you use one or the other, you will get slightly different looking numbers, but it's going to be pretty much the same. So now let's get into working out both, because I'm very excited. I got this back. All right, this is the first time, you working with me in this video. All right, this is me getting excited about utilizing the TI-84 Plus on the desktop rather than just having it handheld, okay? And I will point something out about that for you to be able to use as well, okay? Now, let's say we wanted to use the z-table. Well, for a problem like this, you have to kind of break it down into its parts, because obviously the z-table is not set up to find by default areas between two numbers. It's actually set up by default to solve or find an area up to a z-score. So what this means is all of these areas are to the left of a z-value, okay? So that means you have to break up this statement basically into this subtraction operation, all right, of the 2 areas. So you're going to find each of the 2 areas for each of the 2 z-scores and then subtract the smaller from the bigger, because we want positive probability values. We don't deal with negative probability, all right? So that's why you see the first one is the probability of z up to negative 2.23, which is the bigger one. It's more positive, right, quote unquote. So if I were to shade using the yellow highlighter, you see I'm going all the way up to the second red line. And that's an area we're going to find first. And then we're going to subtract from that the area going up to, let me use a more, there we go. We're going to go up to, for the second area, negative 2.64. I don't know why my pen was glitching there. But that blue that turned green when it mixed with yellow, okay, that area is going to be subtracted from the yellow area. And that's going to leave the area that's that's shaded in this purple fuchsia color. And that's how we're going to get that in the middle or in between, okay, this in between case. So you probably learned this in class. This is just a little refresher. And it's very important to know when you're dealing with the z-table. But heads up, when you use the calculator or some computer software, you may or may not have to worry about that. And that's the beauty of using a calculator for situations like this. So let's quickly find these areas. I'm actually going to zoom in a little bit because it may be kind of hard to see these numbers. There's a lot of numbers here. So to find negative 2.23, here's negative 2.2. My mouse is circling it, and I'm going to go over until I hit 0.03, that hundredths place of that z-score. And the probability or area for that specific, up to that specific z-score is negative 0.0129. Okay. I feel like when I've said negative a lot, I'm going to just keep saying it, but nope, we do not want to get that mixed up. So the area up to the smaller z-score to negative 2.64. So here's negative 2.6. I'm going to track over until I hit 0.04. All right, so where they cross at is 0.0041. So again, make sure you're subtracting the smaller area from the bigger area, right? So when we do that, this is what we get. We get 0.0088. So again, if you use the Z table, Z chart, this is how your answer will come out, something like that. But now let's look at if you use a calculator. And the reason why I'm using the TI-84 is because it is the most commonly used calculator in statistics classes, at least for introductory statistics. A lot of other classes may use Excel, JMP, I think is what it's called. Some people that use Pearson, they use StatCrunch. There's a whole lot of different software and even online calculators that you could utilize. All right, so now let me show you how we get to where we need to get to in order to do this on the calculator. All right, so anytime you're dealing with area probability, you're going to go to this menu right here, DISTR distribution, right? And so we have to click second and then vars. All right, there's only two here that you choose from, but we're going to stick to that first menu that we're already in. Okay, and so we're going to go to normal CDF because the point of these questions, it's dealing with area up to or through a set of values. It's not just at a specific value. That would be PDF. Now, PDF stands for probability density function. CDF stands for cumulative density function. So the word cumulative is the tip off, okay? And so that's why we're going to use it because we are dealing with a cumulative set of Z values, or if it were X values, same thing. So again, if you're using the TI-84, this is what it looks like. The TI-83 is different. It's just going to pop up on your main screen. It'll say normal CDF, open parentheses, and then you got to fill in the rest. Well, this is what you fill in, the lower, the upper, the mean, and standard deviation. Since we are dealing with the Z-scores, we're going to leave the mean and the standard deviation exactly as they are, because again, that represents standard normal distribution. That's why I wrote out that denotation next to the chart. Now, again, you can do the same sort of thing here where you do each one, right? You leave negative 1899, which represents infinity. And then you can type the upper, which are the two Z-scores that we just did before on paper with the Z table, right? 2.23. Whoops, let me click out of that. I don't know what I did. Do I do delete? Okay, so I'm getting back into utilizing this calculator with my keyboard, so that's why I had like ran into a little altercation there. But anyways, you can do like that, but I mentioned you don't have to do that. What you can do instead is you can type both of them, just like you see how they handed you the problem. It's from negative 2.64 to negative 2.23. You can type that same thing out. And there I go again doing the same thing. All right, let me do delete, 6, 4. Okay. All right, so I'm going to make sure I'm typing the minimization symbol instead of the subtraction button. If you have a full keyboard with the number pad, don't click. You're basically going to click this subtraction button that you see at the very bottom of the calculator, okay? Because you want that to represent negative, okay, for these numbers. Anyways, all technicality aside, we have the lower shown there, negative 2.64, the upper, negative 2.23. Leave 0 and 1 as they are, and we're going to paste, and we're going to click enter, and there's our answer. All right, let me see, can I zoom in? I can't, okay, that's fine. So you should be able to still see it, but 0.008728, not exactly 0.0088, but it's because, again, when you use the z-table, you're dealing with approximated values. So you're taking two approximated values, two rounded values, and then you're subtracting them, and that's how you get 0.0088, okay? But a calculator or computer software, they're going to use more digits. That's why I said it's more precise in their calculations. They're not going to just hand you a rounded value. They're going to give you exactly what that number is, even if you don't see more of the digits, because there may be more, you know. So just keep that in mind. It's going to be a little bit different, but that's pretty much the same. Okay. Just know how they're different, right? So with all that being said, we have answered the question, and this is our probability right here. And I hope this was helpful for you, but definitely let us know if you have any other questions or would like to follow up more with reviewing this. And we look forward to working with you in the future again.